Imagine you are sitting on a roller coaster. It slowly climbs higher and higher until it reaches the very top. For a brief moment, everything becomes silent. The train is almost standing still. No speed, no motion. Yet everyone knows that in just a few seconds, this quiet train will rush down at nearly 100 kilometers per hour. Here's the question: where is all that energy hiding? Now think about something much simpler. I'm holding a cricket ball in my hand. It's not moving. Would you say it has no energy? Most people would. But if I lift it above my head and accidentally let go, it can hurt someone standing below. Why? And what about this rubber band? It's completely still. But the moment I let go, snap. It flies across the room. Again, where did that energy come from? Today, we are going to answer these questions, and by the end of this video, I promise you will start noticing physics everywhere, not just in your textbook, but in your everyday life. Before we talk about potential energy and kinetic energy, let's understand one simple idea. What is energy? Here's something interesting. You have never actually seen energy. You have seen a fan spinning, a bulb glowing, a football flying through the air, a waterfall crashing onto rocks. But you have never seen energy itself. You only see what energy does. That's why scientists define energy as the ability to do work. In simple words, if something can cause a change, move an object, lift it, heat it, or make it do something, it has energy. And here's the amazing part: everything around us depends on energy. The food you eat, the phone in your hand, the sun that shines every morning, even your heartbeat. Without energy, nothing in our universe would ever happen. Now let's come back to our cricket ball. Right now, it's resting in my hand. Nothing special. But watch what happens. I slowly lift it higher. Has the ball become heavier? No. Has it started moving? No. So what changed? Something invisible. By lifting the ball, I have stored energy in it simply because of its position. This is called potential energy. Potential energy is stored energy. It's energy waiting for the right moment to be released. Think about a stretched rubber band, a compressed spring, water stored behind a dam, a coconut hanging high on a tree. None of these are moving, yet every one of them is ready to do work. It's almost like they are patiently waiting for someone to release the energy they have been storing. That's why I like calling potential energy hidden energy. Because you can't see it, but you can definitely see what happens when it's released. Now let's return to our cricket ball. The moment I let go, the ball begins to fall. At first, it's moving slowly, then faster and faster. Did the potential energy disappear? No. Nature doesn't like wasting energy. Instead, that stored energy changes into a completely different form, the energy of motion. This is called kinetic energy. The moment an object starts moving, it possesses kinetic energy. A running athlete, a speeding train, a flying bird, a falling raindrop, a football kicked across a field. Different objects, one common idea. They are all moving, and because they are moving, they all have kinetic energy. Now let me ask you something. Imagine two identical cricket balls. One is gently thrown towards you. The other is hit for a six by your favorite batsman. Which one would you rather catch? Obviously, the slower one. But why? They are exactly the same ball. The only difference is speed. The faster a moving object travels, the more kinetic energy it possesses. That's why a fast moving car is far more dangerous than a slow moving one. A small increase in speed creates a surprisingly large increase in energy. And that single idea explains everything from road safety to sports to rocket launches. So now we know something fascinating. A stationary object can store energy. A moving object carries energy. But here's the real mystery. Can these two forms of energy change into each other continuously? The answer is yes. And once you understand that transformation, you will never look at a swing, a roller coaster, or even a simple game of cricket the same way again. Let's find out how. Let's go back to where we started, the roller coaster. As the roller coaster slowly climbs to the top, it's doing something much more important than carrying passengers. With every meter it climbs, it's storing more and more potential energy. Think of it like charging a giant battery. The higher it goes, the more energy it stores. Finally, it reaches the highest point. For just one brief moment, its speed is almost zero. Its kinetic energy is almost zero, but its potential energy is at its maximum. Now, watch carefully. The moment it starts moving downhill, something beautiful happens. The stored potential energy begins changing into kinetic energy. As the roller coaster moves faster, its kinetic energy increases. At the same time, its potential energy decreases. Nothing is lost, nothing is created. The energy simply changes its form, and this doesn't happen only on roller coasters. It happens on a playground every single day. Imagine a child on a swing. As the swing rises, it slows down. Its kinetic energy decreases. Its potential energy increases. At the highest point, the swing almost stops. Maximum potential energy and minimum kinetic energy. Then gravity takes over. The swing comes back down. Potential energy changes back into kinetic energy. The swing speeds up. This beautiful exchange continues again and again and again. Without realizing it, every child playing on a swing is watching one of the physics' greatest stories unfold. Now that you have understood the story, the formula becomes surprisingly easy. Let's begin with potential energy. Potential energy equals to mgh. Don't worry about memorizing it, just understand it. M represents mass. A heavier object stores more energy. G is the acceleration due to gravity. On Earth, it's almost always the same. And H represents height. The higher an object is lifted, the more potential energy it stores. Simple. Now let's look at kinetic energy. Its formula is kinetic energy equals to half mv square. Notice something interesting? Mass is important, but speed is even more important because speed is squared. That means if the speed doubles, the kinetic energy becomes 4 times greater, not double, 4 times. And that's exactly why road safety matters. A car traveling just a little faster doesn't become just a little more dangerous. It carries much more energy. Physics explains what our eyes cannot see. Now look around you, the fan spinning above your head, the lift moving between floors, rain falling outside your window, a football flying across a playground, water rushing down a waterfall, a bird taking off into the sky. Every one of these is telling the same story. Energy changing from one form to another, again and again and again. Once you understand this, you stop seeing physics as a school subject. You start seeing it as the language of nature. Physics isn't something that only exists inside classrooms. It exists in every step you take, every jump you make, every game you play, every sunrise you watch. The world hasn't changed. Only the way you look at it has. So the next time someone asks you, what's the difference between potential energy and kinetic energy? Don't start with a definition. Tell them about the roller coaster waiting at the top of the hill. Tell them about the cricket ball falling towards the ground. Tell them about the child on a swing. Because once someone understands those stories, they will never forget the science behind them. If you enjoyed this journey into the hidden world of energy, don't forget to like this video and share it with someone who thinks physics is difficult. And if you are curious about the science behind the world around you, subscribe to the channel. Because every week we will explore another fascinating question together. Until then, keep asking questions, keep observing the world. Because physics isn't hiding inside your textbook. It's happening around you every single second.